talking about the effects of scale factor. I'm sorry, I'm going to be going through it quickly. I have to be out of the building in a few minutes, so I will do as quickly as I can. The first thing we're going to talk about is perimeter, and perimeter is the distance around a figure. To find the perimeter, you have to add up the distances of each of the sides. Now, distance is one-dimensional. It has the dimension only of length, and so perimeter is a one-dimensional measurement. And we find it by adding up all of the sides together. In this case, the perimeter is 6 units to the power of 1. It's unnecessary to write that 1. The reason I am is just so that you know, when you're measuring something that's one-dimensional, it's implied that it is to the power of 1 there. When you're measuring something that is two-dimensional, such as area, there would be a 2 there, but you won't see it. So, when we apply scale factor is by definition the number we multiply all of our sides by. Here we can see our scale factor is 3. So I'm going to take my side, the blue side that was 1, and I'm going to multiply it by 3. My side that was 2, the red side, multiply it by that scale factor of 3. The other blue side, which was 1, multiply it by the scale factor of 3. And the other side, which was 2, multiply it by the scale factor of 3. I'm also going to write this algebraically so that we can see a pattern. And so this side used to be 1. We multiplied it by a scale factor of 3, and I'm going to write f to represent scale factor, just so we can see how exactly the scale factor affecting it, regardless of what the scale factor is. Here I took the scale factor, and I multiplied it by the side of 2. Here I took the original side, multiplied it by a scale factor of 3. Here I took the original side, multiply it by a scale factor of 3. So you can see that when you're applying scale factor, you always take the original side and you multiply it by whatever the scale factor is. To find perimeter, you add those sides up. So to find the total perimeter, because we know all the sides in this case, this would have a side of 3, this side would be 6 units long, this side would be 3 units long, this side would be 6 units long. And if I added them up together, I have 6 plus 6 is 12, and 6 more because 3 plus 3 is 6 is 18. The perimeter would be 18 units. Again, you don't need to write the 1, it is implied, but because perimeter is one-dimensional. If I wanted to simplify my algebraic expression, here I have 1f, here I have 2f, 1f, 2f. Now remember that multiplication replaces addition, so 1 times f is the same as just having 1 group of f. 2 times f is like having 2 groups of f that you added together. 1 times f again is 1 group of f, 2 times f is 2 groups of f, or f plus f. If we add them all together in order to simplify our expression, instead of adding f plus f plus f plus f plus f plus f 6 times, instead that simplifies to 6 times f. Now the only reason that it's times 6 in this case is because our original perimeter was 6. So you can always take your original perimeter, whatever it is, and you can always multiply it by your scale factor to get the new area. So what we could have done instead of laying all of this out is we could have just taken the original area of 6, seen that the scale factor was 3, and went 6 times 3 to get my new perimeter, which would have given us 18 as well. There are also some patterns that happen with area, so we're going to look at that now. We have the same shapes, but instead we are looking at area. Area is the number of square units that fit inside of a two-dimensional surface. It is measured in squares because squares take up space. They also have 2 dimensions. In this first rectangle, or the original rectangle, I can see that the area is 2 because 2 square units fit inside of it. So A is going to stand for original area. So the original area was 2 units squared, or to the power of 2. It helps me to remember this by knowing the squares are 2-dimensional, area is 2-dimensional, so it is to the power of 2 for your units, or square units. To to find area, you can always multiply the side lengths by each other. So I could have went 1 times 2 to get the area of 2 as well. Now if I take a scale factor of 3, again, scale factor by definition is the number that you multiply the sides by. That means I take my side that used to be 1 and I multiply it by 3. I take my side that used to be 2 and I multiply it by 3. Now just like we did for area, I'm going to rewrite those as algebraic expressions so that we can see if there's a pattern that would work for any scale factor. So here I took my original side and I multiplied it by my scale factor. Here I took my original side, multiplied it by my scale factor. Now to find area, just like we saw here, we can always multiply our 2 side lengths together. So to find the area of this one, I could go 1 times 3, because that gives me this side over here. And then I could go times, because I'm finding area, times the other side of 2 times my scale factor of 3, this is my other side, would give me an area of, let's see, 1 times 3 is 3, 2 times 3 is 6, 6 times 3 is 18 units squared again, because that means there's 18 two-dimensional squares that could fit inside of here. Now, we're going to rewrite the same thing just like we did last time using our algebraic expressions. So this would have been 1 times f, f standing for scale factor, times, this can use the dot there too, times 2 times f. Now what we're going to do is called simplifying our algebraic expression, and we're going to use the commutative property initially to do that. So I'm going to put all my numbers together. So my 1 and my 2. Commutative property means I can rearrange the order of multiplication without changing its results. And then I have my 2 f's together, so f times f. Now I can simplify it from here because I know what 1 times 2 is. 1 times 2 is 2. And I know that anytime we multiply something by itself, we can use an exponent for that. And I see that I'm multiplying the f by itself twice. So my base is f, and so I'm multiplying by itself twice, the exponent is squared. The reason that we're multiplying it by 2 is simply because the original area was 2. So we took the original area and we multiplied it by our scale factor squared. So if you didn't want to lay out all this problem like we started, you could have just taken that and said, okay, our original area was 2, I can multiply it by the scale factor squared. In this case, the scale factor is 3, so it would have been 3 squared. So this is our scale factor squared, this is our original area, and I would have saw order of operations, I do exponents first. 3 times 3 is 9, 9 times 2 would have also given me my area of 18 units squared. Notice that when we applied scale factor, our shape didn't change, it stayed a rectangle. And because it's a rectangle, the angles in this were 90 degrees, the angles in this are also 90 degrees. So multiplying our sides by a given number, which is called a scale factor, does not change the angle measurements or the name or type of shape that it is. So when it says rules for effects of scale factor, the first thing to know is angle measurements don't change. They stay the same. The name of the shape doesn't change. It stays the same. Because it was a rectangle, stayed a rectangle. 90-degree angles, stayed 90-degree angles. The things that did change were perimeter and area. We say, how did they change? Well, perimeter changed by taking the original perimeter, and that original perimeter got multiplied by the scale factor to the power of 1. Now, again, right to the power of 1 is unnecessary because to the power of 1 doesn't change it. The only reason I'm writing it is to help us remember. Perimeter is one-dimensional. It's just the dimension of length. So that's why it's the power of 1. Whereas when it asks us the area of the shape, how did it change? It changed by taking the original area and it got multiplied by the scale factor squared, or to the power of 2. And like I said, it helps me remember that because area is two-dimensional. It has length and width. It's measured in squares, so it's two-dimensional, so it has the two, whereas perimeter is one-dimensional, so it's measured in one. Okay, so now we're going to use those rules that we saw about perimeter being multiplied by scale factor, area being multiplied by scale factor squared, the name of the shape not changing, and the angle measurements not changing. If I have a rectangle, I can find the original perimeter of it, like always, by adding up the lengths of the sides. So I could go, this side is 2, and this side is 2, this side is 3, so this side is 3. So the perimeter would be 3 plus 3 is 6, plus 2 is 8, plus 2 is 10. So the original perimeter is 10 units. Whenever you don't know what the unit is, like centimeters, inches, feet, then you can just label it plain old units. The original area, you can find always by multiplying the base times the height, because number of square units that fit inside. And if I said that there were 3 this way, 2 this way, it would have an original area of 2 times 3, which is 6 units squared. Now, if I did not want to draw my new picture, give it dimensions, and calculate it, I could use the rules that we came up with. And that was for perimeter. I'm going to have P represent the original perimeter. That I could take my original perimeter, and we found that I could multiply it by the scale factor. So if I was going to use this, I would have my original perimeter, which was 10, multiplied by my scale factor, which in this case is 4, and I could tell without having to do any more work than that, that my new perimeter would be 40 units. You can say to the power of 1, but it's unnecessary, but it helps me remember, again, the perimeter is one-dimensional, which is just a dimension of length. I could do the same thing for area. Instead of redrawing everything with area, I know that the rule that we saw was that I could take the original area, which I'm going to say A stands for original area, and I could multiply it by scale factor squared. And I remember that it's squared because area is measured in squares. And so then I say, well, the original area in this case was 6, and the scale factor, again, was 4, and I know that it's squared. Order of operations says I do exponents first, so I have 4 squared, which is 16, and I multiply that by 6. And I know, let's see, to do 6 times 16, what I would do is 6 times 10, which is 60, and 6 times 6, which is 36, and then I would add those up to get 96. So then my area is 96 square units. And again, I remember that square units because area is measured in squares. So if I don't want to draw the new pictures, I just want to show you that you can use these rules that we found about original area times scale factor squared and original perimeter times scale factor to figure out the new ones. If you didn't want to, of course you can always draw that new shape. So let's draw it just to see. If I applied a scale factor of 4, this side would now be 8 because 2 times 4 was 8. The new top side would be 3 times 4, which is 12. Our new perimeter would be 12 plus 12 is 24, plus 8 would be 32, plus 8 would be 40 units. And our new area, and notice how this was 40 units, which we found using our perimeter times scale factor, so it matches there. And our area, we would go 8 times 12, 8 times 10 is 80, 8 times 2 is 16. We put them together, we get an area of 96 units squared. So again, we can use these rules to help us. But if we forget, we can always go back to drawing our rectangle to figure it out. So, most important things that you should have gotten out of this video are right here, with your rules for the effects of scale factor.